Hi, I'm Tanish, and in this video, we're going to do probability of independent and dependent events. Both you and your friend Jake have one piece of candy each, and Jake wants to make a bet where winner takes all. He suggests that you have to roll a die twice, and if both numbers are odd, then you win. But if they aren't, then he wins. So, we're looking for the probability where there are two odds numbers when you roll the die. So I could just list all of these, all the possibilities out and find which ones are odd, right? Like I did list them out. I listed all the possibilities out. And if I look, I have this one is odd, this one's odd, this one's odd, this one's odd. Oh, that's not odd. This one's odd, this one's odd, and this one's odd. These are odd and these are odd. So I could use our understanding from before. The probability of two odd numbers consecutively is the total possibility, which is the 36 numbers here, 36 possibilities here, and there are nine of which are all odd. So it's 9 over 36, which is 1/4. Solving this problem in this method is just you torturing yourself. But there is a better way, a much simpler way to do this. And when we gotta realize something in this problem, when I rolled the dice for the first time, I had these as our possibilities. There were one, two, three, four, five, six, right? And when I rolled it the second time, I still had the same possibilities. There were one, two, three, four, five, and six. Those never the possibilities never changed. So did the probability. The probability of the second time I rolled it stayed the same, and it went regardless of what number was chosen the first time. It never affected the number I rolled the second time. So knowing that this is what we call an independent event, where the number no matter how many times you roll this will do this event, do this probability experiment, the outcomes have the same possibilities as they had the last time, and so on. So this is an independent event. So you can only solve this way if this is an independent event, which it is, because I proved it. So to do that is if I have to find the probability of the both numbers of the dice being odd, let's find the probability of the first die being odd. And we multiplied with the probability of the second die being odd. So the probability of the first die being odd, and that is 1, 3, 5, which is 3 over 6. And the second die is also, well, also 1, 3, 5. So that's also 3 over 6. So 3 over 6 is 1/2, and so that'll be 1/2 times 1/2, which is equal to 1/4. And this is the same number we got from here. Your probability of winning is 1/4, right? That means uh, that means Jake's probability of winning is 3/4, because 100% minus 1/4, 100% minus 1/4, which is basically 100% of 1 minus 1/4 is equal to 3/4. So the rest of the outcomes that are not odd is what he has to win with, right? If you look here, the probability of him winning is much higher than the probability of you winning. You can clearly see Jake is just cheating you right now. Jake, realizing that you've outsmarted him, comes up with a different idea. He pulls out a pouch, and in this pouch, it contains 6 pieces of paper with numbers ranging from 1, 2, 3, 4, 5, and 6. and he says that you have to pick two tickets out, and if these tickets contain two odd numbers, then you win. If they don't contain two odd numbers, then he wins. So, like the last time, our winning condition, our probability of winning is the probability of two odd numbers. So the probability of two odd numbers is basically the probability of the first ticket being odd. So I'm going to call this odd 1 times the probability of the second ticket being odd, which I'll call odd 2. So this is also similar to our previous problem where we have both of these possibilities multiplied against each other. So, but here's something different, all right? When I pick the ticket first, right? When I pick the first ticket, I have to pick from these numbers 1, 2, 3, 4, 5, 6. I'm gonna write them here. 1, 2, 3, 4, 5, 6. That's fine. That's similar to our previous problem. We also picked from these things. Pick from we also got a number ranging from 1 to 6. But if I pick it a second time, you gotta realize instead of this being a die where you can infinitely roll over and over again, we are picking out a piece of paper, right? And when we take out a piece of paper, you won't have that piece of paper remaining. So one of these numbers will be removed, and you won't have them when you're picking out for the second time. So while you have 6 outcomes the first time, the second time you pick out, you have 5 outcomes. That means you lose a number once you pick the first time. So this goes against what we said previously. This is a dependent event. This is a dependent event. This is where our possibilities rely on our previous outcomes. So how do I do this? Well, let's try to do this problem, and let's do it till we reach our problem area. So the probability of the first ticket being odd is simple enough. I just pick one of these things. It's like the same problem. Like it's like before. I have 1, 3, and 5 as my favorable numbers. So that's 3 over 6. Now the probability of this probability of odd the second time is where the issue arises. So I lose a number and then I have these numbers remaining. So when I do a problem, when I try to find the probability of something, I think of this. My trick of understanding how to do this is I think that I already did this. I already found the probability. I already got these two odd tickets. I pulled those two tickets out and they were odd. Okay, so since I got the first ticket out and it was odd, that means all I have remaining are all the even tickets, and I have two odd tickets. I'll just replace them with hashtags because it can be any of these numbers, 1, 3, 5, right? So these are all the possibilities I have remaining. I assume since I've already picked the two odd tickets, right? So since the second time when I pick out of them, I only have two remaining. I only have two odd tickets remaining. So now I have 5 total outcomes and 2 favorable outcomes. So our probability is 1/2 times 2/5 is 1/5. Now you can finally understand that Jake was trying to trick you once again. So what we learned from this entire thing is that Jake is a pathological liar that will try to get your piece of candy by any means necessary. And also when you're trying to find probability, then you have to be careful whether they're independent or dependent events, because that makes a huge difference.